Neuroscience and beyond. Know more, get inspired. Welcome to the Neuroscience and Beyond podcast. My name is William Georgiev and I am a PhD student at the University Medical Center Göttingen in Germany. Together with my PhD colleagues Sabina, Christina and Lenny, we desire to bring science, and especially neuroscience, closer to the general public. In the following episodes, we will talk to various scientists about their inspiration to do science, their research topics, and their opinion on current scientific problems. Today, our guest is Professor Andrea Antal. Professor Antal is a leader at the Non-Invasive Brain Stimulation Lab at the University Medical Center Göttingen. The primary aim of her lab is to develop and establish new non-invasive brain stimulation methods to induce physiological changes in the central nervous system in order to investigate cognition and complex information processing. Professor Antal's lab is using transcranial magnetic stimulation, transcranial current stimulation, and random noise stimulation to externally induce changes in the brain activity necessary to induce long-lasting modifications in the human brain. In terms of effectiveness, these methods have therapeutic potential for the treatment of diseases such as depression and chronic pain. Before we begin, I'd like to mention that this podcast is separate from my research position at the University Medical Center Göttingen. This podcast is supported by the International Max Planck Research School for Neurosciences in Göttingen, as well as by the Cluster of Excellence Multiscale Bioimaging in Göttingen. And now, please enjoy the talk with Professor Andrea Antal. Welcome, Professor Antal, to our podcast. I'm very happy that you accepted our invitation, and I'm looking forward to our exciting discussion today. So, it's now a tradition in our podcast to ask the guests what actually inspired you to get into science.
First, thank you very much for the invitation. I am very happy to be here and talk about science, neuroscience, and beyond. So, I was born in Hungary, and I studied in Hungary. But before, in the secondary school, in the 80s, I met a very nice person. I think I was in 16 and 17, and she did research. I said, okay, what does it mean? Something with animals, and maybe I have to study biology. And I think this was the first input for me to be a scientist. Unfortunately, that time in Hungary, we had only 3 faculties for biology. So I started in Szeged. This is the southern part of the country. It's a university, very nice university city. And we were only 16 students.
Wow. That little. Was it because there was no facility or less people who teach, or there were less people who were interested in this?
I really don't know. I think the university that time was big too. So but in the 80s, you can imagine that we had no computers, no internet, almost nothing.
Yeah.
We had
different.
paper and pen and books and normal telephones. And science that time was a little bit slower.
Yeah. And then you started your undergrad there, right? And at
Yes.
some point you moved to the US, where
Yes.
you were actually active in several institutes, as long as I remember.
Yes, I got my diploma in 1990, and a few months later, I started my PhD in New York, in the Mount Sinai Medical Center, and so in Hungary, we had different system that time. So first I got the university doctor title. It was in 93. I went back, and the PhD is just started. So I enrolled myself in the PhD system too, and I got a PhD in 98 in cognitive biology from the Medical University.
Mm-hmm, mm-hmm.
Yes, and I was in New York first, and after the lab moved to Omaha, Nebraska.
Oh, wow.
And after my boss moved back, Health Science Center, Brooklyn. In 94, I left the States and I went back to Hungary, and I taught physiology at the Medical University for many years.
What was your topic of your PhD in the US? You said cognitive?
So animal models of Parkinson disease. That time the MPTP model was new. And indeed, I was working with monkeys.
Oh, wow.
So
this is interesting. We are now in the German Primate Center.
Yes.
Yeah. So you went back to Hungary where you taught physiology, and then somehow you ended up in Göttingen.
Yes.
How did it come to that conclusion?
The head of the Department of Clinical Neurophysiology from Göttingen was in Szeged. It was a conference. And he saw me presenting a poster, giving a talk. And in 2000, my phone was ringing, and he told me that, okay, I have a job for you. And I was really thinking about it because my daughter was small, so 3 years old. My mother was very ill. Nevertheless, we decided to leave the country, came here, and I started a postdoc research, postdoc direction here, and I stayed here.
Oh, wow. So you liked it. We see a pattern now. I don't know, you're already the third or fourth person who was actively recruited during a conference to come to Göttingen. Also, already several people. Maybe there was some strategy to, increase neuroscience in Göttingen. And how do you feel now in the city of science, Göttingen?
So I have been working here for 23 years now. The clinical neurophysiology is closed because the head of the department, Professor Paulus, is retired. We are integrated in the neurology. I am the head of the non-invasive brain stimulation laboratory, and I think we reached a lot during these 22 years.
So you're now the head of this department. Maybe now it's a
laboratory,
time.
Yes.
Laboratory,
yes.
It's a department.
And responsible for research.
Yes. It's a good point now maybe to go into your research and tell us what are you actually doing in this laboratory.
So we are using transcranial brain stimulation methods. Generally, there are two big groups. Magnetic stimulation, it's a little bit older. And what is new and what was really born in Göttingen, the low-intensity transcranial electrical stimulation. Here, the direct current stimulation is when we are using currents like anodal, cathodal. This is the classical definition. Or we are using oscillating current, so alternating current stimulations is called TACS. The first paper was published from my group. It's 2006 or 2008, and we started with this kind of stimulation because the brain is working with oscillations. And the main aim would be, so if you can imagine that we have a neurological or psychiatric disorder, something happens in the brain what is abnormal. Maybe the excitability is lower or higher. Maybe the cortical oscillations are abnormal. So what we are doing, we are applying electrical current or magnetic field that induces an electric current in the brain from outside. When it's possible focally, just for this brain area, there is a problem, and we try to restore. So improve, for example, cognitive performance or motor learning, or helping patients after a stroke or chronic pain, improving the symptomatic of chronic pain. something like this. So the difference is between the pharmacological and to all, let's say, non-pharmacological method, that when you take a pill, it's for the whole body. And we are targeting just the brain, the central nervous system.
If we maybe break down these terms,
Yes.
transcranial, what does it mean? Also the oscillation, and to make it clear that this is non-invasive. So
yes,
meaning
exactly.
Exactly. You don't need to do anything to the brain to open the skull. You just stimulate from the outside.
Exactly. There are, let's say, other methods. Even one older method is electroconvulsive therapy, where they applied several hundred volts.
Wow. This is a
And
lot.
it's still used by very severe depression or this kind of thing. Or we have, for example, deep brain stimulation where they implant electrodes, Parkinson's disease or chronic pain disease. So all methods are non-invasive. We put electrodes on the surface of the scalp, and between these two electrodes or several electrodes, the current is flowing. Or we are using like a coil, a magnetic coil.
This is like a device that stays around the brain. Exactly. And then it sends some magnetic field. And as we know, the brain works with, there is electricity, right?
Yes, exactly.
Therefore, we can influence it. Do you work with humans or monkeys right now, or mice maybe? I don't know if this is possible to do it.
Yeah, I think, it's possible, but it's a clinical department where we are doing research. We are developing new protocols for different kind of disorders, how to treat. That is, of course, we cannot, we can treat a symptom. But we cannot solve the problem. So it's like really like an electrical pill, let's say, or magnetic pill.
Yeah. So let's imagine some person has a certain disorder, and he is allowed to be treated with one of these methods. So what is the standard procedure? They undergo several procedures. They can do it at home, and how long lasts the effect of this treatment, for example?
So it depends on, of course, the disorder and how long the patient has this disorder, what are the other problems if the patient is taking medication or not, because sometimes it's combined with medication. Usually we have to repeat the stimulation at least 10 times. Let's say chronic pain, chronic low back pain, I would say 10 times, but depression, 20, 30 times each day. So this is like a medication because you have to take the pill each day too. Okay, concerning the effects, I would say that after a successful treatment session, the patients have less symptoms, for example, less pain for months. But after, unfortunately, they have to come back. So it's this is what I mean, that if something, if there are anatomical or very strong physiological change in the brain, we cannot reach these cortical or subcortical areas many times.
So somehow you induce some change in the brain that lasts this amount of time, and then because of the disease that this patient has, again this change goes wrong, so to say.
Yes.
And then they need to be treated again. And this is more like, what is your impression? Is this some brain region have like damaged receptors, or they release less neurotransmitters, or what could be the undergoing?
So it can be the less neurotransmitters, or the connections between the neurons are abnormal. We call it maladaptive plasticity in the brain. And what we induce an adaptive plasticity, or try to decrease the amount of these abnormal changes. For example, in chronic pain, this is a very good example because the patients are very sensitive even for a very quick stimuli.
Okay.
Because the brain somehow, let's say, remembers for this kind of brain. So, and the excitability is changing in the brain, and we would like to target these cortical areas and giving impulses to the brain from outside that learn it. Learn it, and we are stimulating, of course, like 20-30 minutes per day. And your question was here that in the clinic or at home. Yes, so first we start, of course, in the clinic, but during the corona times, the pandemic time, it was very, very difficult because all of the clinical studies were stopped. And several companies developed home stimulation devices. For magnetic stimulation is impossible. However, for electrical stimulation is not a big problem.
Why is it impossible for magnetic stimulation?
Because it's difficult to induce like a huge magnetic field. So, so the change of the magnetic field induces the electrical field in the brain. And these equipments are really very complicated and very expensive. The electrical stimulation devices are small. And now we have 2-3 companies in Europe who are producing these stimulators with like a cap where we can place the electrodes a given position according to the disorders or symptoms. And we train the patients first in the clinic. And after they take the stimulator saves everything. So the impedances, what happened when they did the stimulation. Of course, we block the time between 2 stimulation sessions because patients sometimes believe that longer is better and stronger is better.
Wow.
Or more frequently would be better is not the case. So we can pre-program the stimulators and they can use it at home, and it's working very well. So this is like a little bit like telemedicine. We are going in this direction.
I mean, a lot of branches of medicine are going also. I heard about people with skin doctors, dermatologists. They're like, oh, I want to do this online. Okay, when you can do it, then do it. If you can help people, do it. But so we established this is non-invasive, and it treats some parts of symptoms. Which disease are more susceptible for treatment? Or maybe not all of them, but can you give us some examples?
Yes. So, of course, during the last 20 years, we had plenty of clinical studies. So Göttingen has a leading position. But the other universities, for example, in Germany, Berlin, Tübingen, in the United States, Boston,
of course,
New York, Washington, D.C., in United Kingdom, London, Oxford, Cambridge, so the big universities. So we published plenty of like meta-analysis, reviews, and we have something like guidelines. The International Federation of Clinical Neurophysiology is like an umbrella for these guidelines. And what we are doing that every 2-3 years we collect all of the clinical data that published using this kind of methods, and we categorize the studies, and we can see that way how is the efficacy of a given protocol, for example, in chronic pain, and we publish it. So, what is top now? Depression. Depression treatment using, of course, the old method. It's called repetitive magnetic stimulation, or using anodal direct current stimulation. The position is the left side dorsal, left side frontal, dorsal prefrontal cortex, and so according to our experience, for example, here in Göttingen, I would say that 70-80% of the patients react very well. The second big group is chronic pain. The problem is it's a little bit heterogeneous. Because it depends on why patients have pain and where. For example, a nice group, it's fibromyalgia. Patients have pain, different part of the body without organical reasons, and we had now a very nice study, and I would say 80% success rate, and the patients stimulated themselves at home. So this was our first study in this patient population. So I would say, depression, chronic pain or types of chronic pain, migraine, so headaches, sometimes stroke, depends on the type of stroke. We had less success in Parkinson patients, and we were yet successful using alternating, so oscillating current in mild cognitive impairment. So we not even diagnosed subject, but elderly subject, where this process starts.
So maybe Parkinson, the reason is because the origin is in the deep nuclei and you cannot reach it. I want to go to this study that you mentioned. I think, is this the one that Krishna participated?
Yes, exactly.
Before that, just briefly to explain, you mentioned this term plasticity. What is, we constantly hear the brain is plastic, the brain is plastic. What does this mean?
So during, for example, learning or during transcranial brain stimulation, the brain can make new connections. So the neurons can make new connections, or more or less neurotransmitters are released. So like new pathways. And concerning brain stimulation, we call it long-term potentiation like. So it look like that we are inducing plasticity, because it's not exactly the same process. When we are using this kind of stimulation, of course, we do not know what's happening in the brain. We do not have electrodes in the brain to measure the activity. So maybe we are inhibiting the excitatory neurons or exciting the excitatory neurons, so that the brain is extremely complex. And we have an excitatory inhibitory balance in the brain. And probably this is what we are changing.
And also in terms of plasticity, we have new connection, but we also strengthen or weaken some of the connections, correct? Interesting. I was thinking now, when we have magnetic, so MRI, functional magnetic resonance imaging, for example, very often we see, let's say, subjects that undergo they are participating in some research, and they see some image, let's say a house, and some kind of a brain region activates itself, right? Meaning that, okay, maybe the information about this image is somehow stored into this brain region. When you stimulate with the current or the magnetic stimulation some region that you said, have you heard patients reporting, oh, I see now something flashes from...
Yeah, of course. So when we stimulate the visual cortex, for example, using this magnetic stimuli, we can induce phosphene perception.
Yeah. That's very interesting.
So we can even induce moving phosphenes when we are stimulating the middle temporal areas, so where we have the motion perception center, let's say, in the cortex. Yeah, it's absolute. So the big difference between the two methods. So when we are using magnetic stimulation, we can evoke like potentials in the brain. It's really very strong. However, when we are using electrical stimulation, we can just sustain the probability of firing neurons, but not inducing.
Yeah. I see. It's more natural, so to say.
Yes, exactly. So we are pushing the brain in one or other direction, let's say.
It's very interesting. How do you evaluate the success? So I assume you evaluate these patients before the treatment somehow, and then after. What are the criteria that you say, okay, we have 80% success in this treatment?
Okay, so it depends on the type of the disorder.
Yeah.
For example, in chronic pain, what we can do, we have different type of questionnaires. Patients have pain diaries. And the most important for me, of course, the subjective feelings,
Yeah.
what the patients are telling us. If it's possible, we can measure something like electroencephalogram, so the mass cortical activity. We can combine the stimulation now with MRI, fMRI. So we can measure the excitability changes in the brain during this treatment session, or using magnetic stimulation. This method is used for diagnosis too. And when we are applying stimuli with different durations, so I mean the breaks between two students with different duration, we can measure between two like cortical areas, the inhibitory and excitatory relationship, let's say. So we have now, let's say, objective methods.
Yeah, you have also the subjective, which is very nice.
Nevertheless, it's most important for us what the patient report after stimulation, of course, because they feel pain, they are depressed.
Exactly. At the end, we want the outcome to be positive for the patient, regardless of some of the measurements. They might show something, but okay, if you are...
and concerning this point, of course, we have placebo response too. So it's not a question. If you don't have a placebo response in your study, you did something wrong. Okay. So it's definite. So, and therefore, when we have a clinical study and we are testing a protocol, we always have something like a real stimulation condition, a placebo condition, and we have like an active control condition where we put the electrode somewhere else or using other type of stimulation.
So it's really controlled.
Absolute, and these conditions are blinded. So the patients do not know what they get. The experimenters, so the PhD students, for example, and even the person who is doing the statistical analysis.
And so this is how we produce highly valuable data that is reproducible.
Yes. And at the end, when everything is ready, we open this blinding, and if we are successful, we can publish the data very well. But not, so we have to submit it several times.
What do you do if it's, let's say, you invest so much time and effort in a research project, let's say 1-2 years, and then you do it blind, everything is very precise, but at the end the outcome is not the desired. Maybe this data will not be published. Do you somehow use it in your community to share, okay, guys, this is not working? Or how does it work?
So usually, so in my group, we do not wait until 2-3 years. So we always piloting. That, okay, we have a new protocol. The problem is with the brain stimulation methods that there are plenty of parameters what you can change. So it's a never-ending story.
Yeah, that's true.
And the best would be to adapt the protocol to the pathology of the patient. But it's almost impossible because there is a variability, so individual variability. And so we always try to find like a compromise. This stimulation duration, this intensity, this frequency or phase or something like this. And we are piloting. So first we just stimulate 5, 6, 8 patients or subjects. And if a protocol is not working in this small group, it will not work, I think, in 20 subjects either. And when we find a good protocol, after we start with a bigger, like phase 2 clinical study.
I see. Of course. I mean, you don't want to invest time and effort before knowing.
Yeah. Nevertheless, it can happen that we have a very strong placebo effect, what I mentioned before. Chronic pain patients or migraine studies is not rare that 30% of the placebo-stimulated patients respond. And sometimes we cannot find a significant difference between the outcomes of the placebo stimulation and real stimulation. Nevertheless, it does not mean that the stimulation has no effect. It means that between these outcomes or outcomes are not the best ones. And that way we compare the baseline with the after stimulation values. And we report that, okay, placebo effect was there.
Yes, but this is correct. You report what you observed. This is, I think we kind of abandoned somehow descriptive science because nowadays everything should be, I solved this process and this disease is eradicated or whatever. We will cure it. We have the pill. No, we don't have any clue in most of the cases, or a little bit. And kind of descriptive science, we did this. This is the outcome. If you think this is meaningful, go ahead and continue. I think this is exactly how it should be done. I did a study, observed several effects. Here is the data. That's it. I cannot tell anything more about it.
Yeah, it's true. Nevertheless, the problem is that if you have something like negative results, so it's not working in the direction what it was expected, it's very difficult to publish these data. Even, for example, in our area, brain stimulation area, 10 years ago, it was impossible to publish negative or no, so no results, let's say. It was just impossible.
It's somehow, we had this in one of our episodes, it's somehow sad because if you publish this, you can already alarm the community. Okay, there is maybe some problems in this. Either try to change it or don't use these protocols.
Yes. Right? And so I always wanted to open like a internet page, a blog or something like for negative results that other groups do not repeat.
Exactly.
These sometimes we are making mistakes too. So it happens.
It turned out there is some web page about this. I don't know in which domain, but there is something going on. Okay, so these two stimulations, magnetic and current stimulation, you mentioned treatment of patients. Is there any age limit, and do you recommend in case some children have some cognitive impairments? Is this safe for children or not?
There are studies in this direction too. Not in Göttingen, because it's an adult department. However, if you think about it, that children have smaller head, smaller brain, the thickness of the bones are not like in adults. Of course, you have to adapt the stimulation protocol, what we are using with adults. And indeed, there are some contradictory data this direction. In Germany, Kiel, University Kiel, did a lot of research in so trying to figure out what kind of protocols can be used, for example, in children with depression or hyperactivity disorders. But there are not so many studies. However, I would not stimulate healthy children. Indeed, I get a lot of phone calls from parents. The child is not good in mathematics or whatever in the school. I heard about the stimulation and about to buy a stimulator. Where should I put the red and blue?
Oh, wow, they already have it. Wow.
Yes, because this is the problem. It's cheap.
Oh, wow.
And you can buy it on eBay, for example.
Oh, this is not, might be dangerous, right?
So yes, so it's not for like neuro enhancement in healthy children. So this is the lower part. The upper part, so of course we have older population. And in this elderly population, I would use the stimulation. And this is what we are doing now, that we are developing new protocols, how to delay the cognitive decline, because unfortunately, it's coming.
Yeah, well. Yeah, maybe in children there is this effect that the brain is still developing, connecting itself.
Yes.
And when you stimulate, maybe you will long-term perturb this connections that are about to occur, and therefore impair maybe even the child instead of contribute to the cognitive capacity in a positive way, right? Since we're on this cognitive enhancement, first of all, what is this cognition at all? Because many people talk about cognition. It's a complex term. And do you recommend enhancing somehow your activity with these methods in adults? I've seen some commercials online saying, okay, we are doing this and you're better in sports, you're better in memorizing things. Is this true in your opinion?
Yeah. So yes, what you said, cognition is a very, very complex and wide term for everything, for memory processes, learning, neuroenhancement. And indeed, as I mentioned, several companies around the world are selling these electrical stimulators for neuroenhancement. For example, for gambling. Stimulating the frontal cortex and your working memory is improving. However, it's I would say that it's not always the case, because we had studies, and in several studies, it's possible to impair working memory to using a protocol, an electrical stimulation protocol. I would suggest everyone who would like to test this stimulation to look for like a center, a clinical center first, talk to experts, and test the stimulator first, or the stimulation condition, or something like this. So neuroenhancement, again, this is a very complex term. Most of the people, healthy people, are stimulating themselves because they want to be better in something. It can be, of course, a psychological process, can be learning, can be memory process, can be physiological activity. Concerning this was, for example, it's very heavily discussed now that if athletes should use this kind of stimulation, and it's doping or not. You cannot measure it if they used it or not.
Yes.
So there are plenty of open questions. In healthy subjects, I would not use this for what? So I don't know. Okay, other side, you can tell me that there are people, for example, who are working during night, or they need a higher level of attention, pilots, or who are driving or something like this. And indeed, with this kind of stimulation, it's possible to increase attentional processes, improving memory. Yes, no question. But where is the border, or where are the borders? Or who can tell you that what to do? Or if we compare it to coffee, because there are plenty of coffee shops, or even marijuana. Where are the borders? Or is it better or worse? Or so I really don't know. So so brain stimulation, unfortunately, concerning neuroenhancement is a little bit gray area. And not well regulated either. In Europe, more or less now, but around the world.
So it's still in its infancy, and it's remained to be developed and established eventually. Well, you mentioned here marijuana and coffee, and maybe there are also people who now are doing this microdosing, meaning they take some psychedelics in certain dose, which I don't know how to comment. Maybe in the future we will have an episode on this. But is this stimulation addictive? The current stimulation or magnetic?
Yeah, it's an interesting question. Because concerning, for example, patient studies. First, at the beginning, I believe that, okay, we always have to increase the intensity of the stimulation or the duration of the stimulation, like with medication, because they get used to it. However, it looks like not. We are using exactly the same intensities or dose of the stimulation, let's say, like before. However, of course, we have a group of patients who are responding, what I mentioned before, and we have these non-responders, like with the pharmacological studies.
What do you do anything in regard to these non-responders? Have you wondered why? What is that? So they don't believe at all. They come with this, and there is no nocebo effect, or is there anything in their physiology that leads to this effect?
Yes. So this is what I really would like to understand until I will be retired. That this is, and indeed, it is a main aim of my group now. That we find parameters that why do we have this variability? It's anatomical, physiological, or, for example, what is very important, and this is why we are combining the stimulation many times with something. So cognitive training, meditation, or sometimes with medication, that the state of the brain. So what the patients or subjects are doing during stimulation or what they did before stimulation. So we have a neuronal history when we start the stimulation. And of course we are different. We have different kind of excitability level in the brain, something like this and sometimes like this. And it's important when we start to stimulate. However, it's very difficult to find these factors. And it would be very good because it would be very nice to know at the beginning that, okay, if I want to use this protocol in a given patient, it will not work. Because there are factors, anatomical or physiological factors.
So it goes more to personalized treatment, let's say, in every domain, actually, with these biomarkers that we have from blood and etc. And I think this is a nice way to treat patients. There is no one pill for one disease, no one treatment procedure for one disease, and I really hope in the following years you will achieve success in this regard. And let's see, maybe we can use it to enhance our ability and achieve more or better results, or treat more disease. Who knows? If I go back to the question with the mild cognitive impairment and this study, it's very interesting. I know Krishna, he's also part of our graduate school, and he's your PhD student. So I remember that you, next to this treatment, patients were taught how to meditate. And this is very fascinating that you were able, during Corona, first to teach them and second to perform this study. Can you please elaborate more on the whole project?
This was a study with patients with fibromyalgia. And the first study we started before Corona. Unfortunately, we were not able to continue the stimulation in the clinic. And of course, we knew from the literature that there are other methods that are working too. And this was like mindfulness meditation. And generally, it's very successful in chronic pain patients. And I say, okay, let's combine the two methods. We know that the direct current stimulation is working when we are stimulating the left side motor cortex, and let's combine with meditation. And we developed a program for meditation, and it's not really just meditation. It's more like an educational program for patients through Zoom. Because if the patients understand what happens in the brain, or what happens during the disorder, or what they have to do others, and what happens during stimulation, we are more successful with the treatment. And we have, as I mentioned, home stimulators now, certified home stimulators with a very nice cap, like a swimming cap, what the patients have to wear during stimulation. And we combined the two methods. And it was really a huge success because plenty of patients came from other parts of Germany. A big disadvantage, if we are doing the stimulation in the clinic, they have to come each day, only for 30 minutes. And they have to find a hotel room, have to stay somewhere in Göttingen. And it's a huge amount of money for patients. Unfortunately, the treatment is not covered by the medical insurance in Germany. And home stimulation, I think the future.
Did you provide them with this home stimulator?
Yeah.
And so they were stimulated and they somehow meditated.
Yes.
Every day.
So of course we cannot control it. But it's same like pharma studies. You cannot control if they are taking the medication or not. So sometimes of course you can take blood. But so they promised that they do that, and I hope they did. And we start 4 weeks meditation, and after 2 weeks stimulation. And of course they continue the meditation. So it's something like this that, so Krishna, my PhD student, indeed had a very good example for that. Imagine the highway, plenty of autos, and after just a nice street outside, few cars running. So the brain is something like the excitability of the brain is changing during meditation, and like calming down. And we start from here and not from here. Plenty of patients, unfortunately, are really stressed.
So in general, so meditation brings you down to certain state that it's perhaps better for the stimulation to kick in, and
something like this. And we hope that way, even for future studies, we can control the state of the brain much better, so we can decrease this variability what we have in brain stimulation studies.
It's also indeed hard. As you said, every person is different capacity, different abilities to concentrate, to stay calm, and stress nowadays is a huge factor in work, at home, outside the street. Although in Göttingen here is very calm city, small city, green, but in big cities it's completely different, right? So would you recommend meditation in general to people?
Yes.
Do you do it actually by yourself?
Yes, I did. I start my day, so each day with yoga.
Oh wow!
So not it's 15 minutes each day, but because I have no time for a longer session, and I got used to it, so it's very important for me. And I think so. Okay, what does it mean, meditation? So maybe if you are in the church, it's exactly the same. Or if you are reading, or if you are working in your yard, this is a type of meditation too. It's
exactly. There are different types, but at the end, everything is a tool to bring your brain into this state that is calm, and then you kind of switch off of the environment. I have tried it when I was in Bulgaria. So I'm from Bulgaria originally, and my city is at the Black Sea, at the coast. So I used to wake up very early, go for a run at the beach, and then sit down and try to meditate for a couple of minutes at the beach. And it was very, very good practice. But now I don't have the beach here.
Yeah, water helps a lot.
Yes. The sound is calming, and it's different when you're at home. Exactly. So all of this research is very nice, and I'm looking forward to see more positive, hopefully, results in treating patients, not only from your work, but also from the community. And many of the things that we discuss are published, and you can find them online if you typed in transcranial magnetic stimulation in the name of our guests, Professor Andrea Antal. You can see very nice reviews. I also checked some of them before the podcast, of course, to prepare. So, however, we know that in our field of science there are plenty of problems, and we want to increase the awareness by talking first to people who are in this field and kind of try to identify what are the most urgent points to be changed, and maybe to find out how to change them in the future, since we are the PhD students and we would like to contribute to our field. So we talked about this reproducibility crisis, that people cannot reproduce their results, and if you work in Göttingen, for example, and somebody from New York tries to do the same experiments, he has different outcome. This is one point. There is also this moment where people who are trained as a PhD student and assume to stay in academia, to continue, they leave academia, they go to the industry, which is per se not bad, but is not the best for our field if the highly skilled people are leaving. We also have this vicious circle of publishing, where you have to design a study, conduct a study in a short amount of time, and then publish positive results, publish more papers in order to get funding to continue your work, which might first stimulate you to conduct the study not in the best way, and second, puts some people with higher funding, bigger funding and bigger possibilities on the map. And for example, guys who are starting, they're hardly noticeable, and this is of course affecting their career in the future. Then we have the publishing per se, where basically everything that is funded by the government, facilities, scientists, we get our salaries from the state, from the taxes, right? We do the work, we invest a lot of time, and then we publish something which goes to some journals that at the end have the rights to sell it, and it's a very vicious circle, as I said. And as a professor, also the aspect of reviewing, you have to review in order to be kind of accepted from the community, but you do it for free, and this is your time. And it's on the other hand, professors, I have a huge respect that how do you manage to do all of these things, plus supervising students, plus teaching, plus trying to think and expand the knowledge, right? Because scientists do this. We kind of work on the verge of knowledge, and we want to have a little bit more, and in order to improve eventually our life and our planet. So I talked a lot. There are many problems. If you decide to pick up some or address more of them, I also want to ask you something else. Since you're a woman, it's very important for me. I personally believe that people should be judged on their abilities, regardless of gender, sex, color, belief, etc., etc. And there is still this kind of a, subconscious belief or even fact that male, especially in the clinic, since you're in the clinic, they kind of suppress females who want to be successful in their careers in many regards. So I stop here.
Okay. You mentioned plenty of problems, so I think we could talk for 24 hours. So let's start with the last one, with this gender problem.
Yes.
Because it really bothers me.
Yeah.
So when we organize, for example, a symposium, workshop, a conference, I always get this direction that, okay, 50% of the speakers should be females, other 50% male. The problem is, now it's getting better, but before, there were not so many good females. The brain stimulation field, and it was almost impossible to find females and good females who could present a study. It's getting better now. However, I don't like this direction, because it should not count someone is male or female, and there are plenty of other problems why females cannot be on a conference, cannot participate. There are cultural problems, historical problems, whatever, and females get pregnant. So we cannot change this problem. The most important for me, when I organize an event, males and females or transgenders or whatever, they get exactly the same amount of chance or possibilities and everything what we can offer by organizing this conference or event. And it really bothers me that females are invited to a conference or to be part of a committee because they have to improve the rate of females. And it happened with me in Göttingen that I was invited to a committee, and I said, okay, do you want to invite me because you see what I reached and how many papers are published and where I am now, or do you want to invite me because I'm a female? And he said, this was a male, he said that because you are female. And I said, forget it.
Yeah, this is very bad.
I'm not,
It's very bad.
It's really, really very bad.
It's from both sides, right? On one side, people are, you have to do it. That's it. These are the requirements. On the other side, people who invite, it's horrible to think like that. I don't understand this.
And unfortunately, we have still problems because we are females. Okay, the situation in the clinic is a little bit more difficult for me because I am not a medical doctor. I'm a biologist. And even after 3 years, 23 years, I feel that they do not accept me because I'm a foreigner, female, who is not a medical doctor.
So.
Although I think I reached that, I have a high impact factor or H index or whatever, but we can count. We are very successful, but until today, I have to fight. And sometimes I don't want to fight anymore. So I would like to be accepted.
Yeah, I see. I understand. I mean, I completely understand.
In my group, there are males, there are females. I'm part of plenty of mentoring programs, not only for females, but for males too. And I am the leader, one of the biggest mentoring program around the world, and this is the International Federation of Clinical Neurophysiology. This is the European, Middle European and Africa chapter. And we just started with this mentoring program.
What is it about? If you may tell us briefly before we continue.
So briefly, we are still looking for mentees and mentors on the field, let's say clinical neurophysiology, what contains a lot of things. For example, brain stimulation. And mentors will help mentees in each part of the life. It can be something like how to get grants, how to write papers, how to find a good postdoc position. Or what about work-life balance?
Yeah.
When should I get children?
Important questions.
Yeah, so important questions. So so I hope it will work.
Yeah, it will work.
But it will not for Germany, but for the whole Europe. And of course, for African countries too.
It's a lot of effort. I respect your desire. It's a lot of effort, but if you stay consistent, as you know, you will eventually succeed, right? It's a very nice program, and I'm looking forward to see it working in some point, right? But when we go back to the problems now, you can continue. I interrupted you here with this. I don't know which part you want to.
Second
address.
one, maybe the work-life balance. I know I don't have work-life balance. I would like to have a work-life balance, but I think the type of science what we are doing, we are working with subjects, not with something like with. Maybe you can plan it better if you are working with Drosophilas or if you are programming something.
Yeah.
But working with even with healthy subjects and patients, it's a very, very difficult process. And sometimes, so indeed, we have to work something like 15 hours if we have deadlines. Someone gets ill or something is not working and the experiments are planned. And sometimes we have breaks. And sometimes we have to work at the weekends. For example, even before I started with animals, as I mentioned, first with the rats and after with monkeys in New York. And I had several monkeys. We had no weekends. So as a PhD student, I worked 3 months continuously because experiments were planned. And monkeys, of course, they don't know it's Saturday or Sunday or something like this. So if you want to teach a monkey, you have to repeat the things each day. And now we have a new generation, new PhD students, and even I noticed that they would like to have this work-life balance. And I think it's good. I don't say that what I'm doing even now, that I'm working 12 hours per day or and I'm getting older and I feel it, that it's too much for my body, for my psychological state. Nevertheless, that even it is not good that, okay, I say that I am earning that amount of money and I will work only between 10 and 5 p.m. So maybe in the industry you can do that. But in the real research, I don't think so that it would work.
But then
I don't know.
This is not a question of changing. Maybe it's more like personal. What do you want to achieve? How much effort do you want to put in? Do you want to be moderate, or do you want to really go high? Yeah.
This is the third point here. What you mentioned. Yeah. Lots of my students, master students, PhD students later looking for a lab. And this is one of the most important questions. Okay, which lab should I choose? And there are competitive labs and there are less competitive labs. And it always depends on, first, what you want to reach. What are your objectives? Would you like to get the Nobel Prize? Want to publish so many papers, and would you like to work more quietly or less? And your personality structure. So, for example, so I always test my students at the beginning, because some of them, just an example, are working with to-do lists, others not. And if I put together a student with to-do list and with someone who hates this to-do list, they cannot work together. It will not function. Even sometimes they cannot sit in the same room. So they have to match. This is like really with dating too. And it's the same for your future life too, that you have to be sure what you want to reach. You have to even look at the personality structure of the boss. It's important sometimes, indeed, females or males. The dynamic of the whole group. And after, you have to decide. And after a few months, you do not feel good in the group, I would suggest you to leave the group and find another position, because this is not for you, and not to try to change yourself or to think that, okay, 2 months more, and when I reach that and that and that, maybe it will be better. Usually it's not getting better.
Yeah, and there are many of these PhD students who they just don't quit and they suffer a lot.
Yeah.
There's burnout and their PIs are not satisfied and they are not satisfied, and at the end is nobody wins.
And the communication is very important from the beginning. To making a plan that, okay, I want to reach that with deadlines. I let my PhD students to suggest me deadlines.
Does it work?
Yeah, they can decide. Of course, I can shape a little bit the timetable, but they are allowed to decide that, okay, I would like to reach that and that and that until. And so there are really plenty of points what you have to consider, and what is important to find, for example, a mentor. So something like a coach.
Yeah. Mentor within the lab, or would you
within the lab or outside? Or someone who can help you when you have problems.
So you would suggest for people to look for PhD students that want that want to continue in academia, or maybe start a PhD, to look for the PI that is matching their personality, more or less, for the colleagues and working environment, atmosphere. Of course, the project should match your interests, and then finding a good mentor. Maybe 4 important things that we sum up.
And it's better outside, because for scientific question or work question, you have your PI.
Yeah.
But there are many other fields where you need help, for example, or just advices, or you just would like to know that how the others did, and it was successful or not successful.
Examples, true. Okay, the mentor part, I have to think about it. But okay, so this is one thing with the PhD student. We have the gender topic. What about, for example, the publishing? How do you feel about this? And the grants, which is...
So publishing is... there are plenty of new papers, of course, plenty of new journals. However, publishing is not easier than before. I think even more complicated. Sometimes I have the feeling. It's more competitive, definitely more competitive. And on different universities, PhD students or different kind of programs, they have different kind of regulations. That how many papers should be accepted, first author or last or whatever. There are huge differences, really huge differences, even in Germany, among universities. So it is possible to publish 2-3 good papers on the field of brain stimulation during 3-4 years. If you are going to the good direction, if there are no problems like corona during the last years, or no other like health problems. However, I have a feeling that lots of programs are pushing students to publish or to read something or perform, and this is not good. And we have different kind of directions. Sometimes it's more difficult to read something on a clinical field, or compared to if you are just programming, developing softwares or questionnaires or whatever, or working with Drosophila.
So yes, it's different for students to produce outcome depending on the subject that they work with. But as a scientist, how do you feel this urge. I need to have this paper so that I get these grants. This is something that makes me worried a lot.
Yes.
Yeah.
Yes, unfortunately, you have to publish several papers before you can get a grant. Sometimes it happens that indeed you have a very good project, and at the beginning, if you are lucky. Of course, so it's a very, very difficult question and difficult answer again, because until today, I don't know. It depends on what. Sometimes I think that, okay, the stars are staying like this, because sometimes we have very, very good projects, very good ones, and they are rejected. And I invest lots of energy, time. I'm writing for months. And other projects, I accepted that they are, and I spent maybe one day writing with the project, and it's not so important, but good, let's say. Of course, it depends on the reviewers. So the grant agencies are choosing 2-3 reviewers, and if the reviewer likes you, you are lucky, not or your boss or the direction. Lots of papers were rejected at the beginning on the brain stimulation field because they said that I don't believe in it. It will not work. And this is it.
It's like personal belief,
no
arguments,
no arguments. Yes.
We have a similar situation of a paper that it's very technical, it's a huge thing, and for whatever reason, there's this reviewer who is saying, I don't believe this, you can see this and that in everything, how do you prove? And nothing. So in my opinion, reviewers should give you suggestions. Okay, maybe you need to improve this and that and make your work better, instead of I don't believe it, I reject it, right? How can we change this this kind of behavior? I don't know.
I don't know either. I am an editor in several journals, and a senior editor, and I hope that I'm always fair, or I really try to be fair. I read the papers, and I try to find suitable reviewers for the paper. But unfortunately, I can see that when we submit from here papers, so for example, yesterday one of my PhD students get just desk rejection. And the direction matched. So, and so I don't know why.
So there is no standardized, like something that, some kind of, I don't know even how to call it, some evaluation that says, okay, because of this and this reason you were rejected. It's rejected, right?
Yeah.
It's bad. You cannot improve your work, right?
Yes, exactly.
How can we overcome this problem? I don't know. I am a little bit
I really don't know. On the other side, now there are, but I mentioned plenty of new journals, and the publishing fee, it's getting, it's very nice that open access. So I like it, that everyone can read it. Nevertheless, it's a high fee, between 2,000 4,000 euros. And these new journals are accepting papers because of the money.
Yeah.
Because they need the money. So there is an other side too, telling the truth.
There is this predator journals, right?
Yes.
One has to be careful.
But even well-established journals need money.
Yeah.
And that way, and it's easy to earn money that way. So, as I mentioned, there are plenty of problems.
We have to work a lot as a young scientist to. But the problem is we're young, right? We don't have experience, and we are not in a position to change anything. For example, someone like you who is already established, and you know how the things work, and you know where the problems are. We would expect some kind of a mutual work between young and people who are well experienced, who have a lot of experience, to kind of suggest some solutions in general, right? Because we are just not in the position, regardless of how much we want to do something. If we are not sitting in the board of I don't know which institution, what can we change, right? Yes, we can demand, but that's it.
So you can make suggestions, written suggestions, for example.
Yeah.
So from my side, my side, the lab or group is like a microcosmos. But I ask my students to reflect, because sometimes maybe my perception, different kind of things, not the best one or not the correct one. I think there are two things that are very important in research too, and this microcosmos, and then empathy, when we are looking together, and reflection, self-reflection, and reflecting the others. And this is what you can do with other professors or committees or groups. So first define what you would like to change, and collect students, postdocs, everyone, even professors, because I know plenty of professors who are not satisfied with the system. But if you are alone, indeed you think that, okay, do you want to invest the energy? Do you have enough motivation? What does it mean for you? So, but for example, from my side, I'm ready for a revolution.
Okay, this is very nice. This was the best. Okay, so maybe we can also start an organization. I'm sure there are plenty, but they're kind of dispersed and they're not coordinated, and everybody fights for his or her own cause, and it's a little bit let's see. And then when the politics kicks in, then things start to get
even in a virtual group would be good at the beginning.
That's a good thing. Now ideas are flying into my head. Okay, so we covered a lot of topics. You mentioned here very nice, you gave very nice advice to people who are about to start PhD. I want to ask you, what advice would you give to PhDs who are finishing their career, their PhD, and they still are not decided, should they continue in academia or should they go to the industry?
Okay. So first, maybe you have to go to something like to a coach or to your mentor or someone, indeed, to feel what do you want? What do you want to reach? It's really a cliche, something like in 5 years, 10 years. Do you want to be a boss? Do you want to be a professor? Do you want to have family? Do you want to earn money?
Are these mutually excluded? Or?
Yes. Oh, sometimes yes. Unfortunately, yes. Yes. And so when students, PhD students, the third, fourth year, they're coming to me, they know already what they want. They are almost 100% sure somewhere is already there. They feel it. Nevertheless, they are unsure. And they just want to have something like support. And they are saying that, okay, now I know that I would like to accept this postdoc position because I have 3 possibilities, and I have a very special system. Do you know these Edgar cards? These postcards, what you can collect a different kind of pups.
No, I don't know.
With different photos, different texts and everything. So I have 1,000 from the Edgar cards. And my students are coming and I tell them that, okay, choose one card with one of your question or one of your problems. And they are choosing 3 cards. And okay, let's talk about the cards. And they are talking about the cards. And after they take the card for 24 hours, and they are allowed to look at the card, they are allowed to think about it, and they come back and they have the solution. But I'm sure that the solution was there before, but they needed something to go in one or the other direction. Industry, of course, if you would like to have work-life balance, it's better to go this direction. And usually researchers are earning more money. Security, again, a huge problem, because usually you get a grant for 2-3 years. And after you have to, during this time, you have to write again plenty of new grants or papers and everything. And it's unsecure what happens with you. Even your supervisor is not able to tell you that, okay, I'm able to pay for you for the next 2 years or not. It's very difficult to get tenure tracks. It would be great. So it would be great for the PhD students. So you finish the PhD, the early stage researchers, let's say that, okay, you get a position for 6 years. Because for this 6 years, you can plan.
Yeah. Yes, it's stressful.
And from female students, I get this question many times: when should I get children? And it's, I don't know, when is the best? It's never the best time, because always something what happens in your life. So if you are going to the direction of academy, of course, you want to write papers, you want to get grants. In Germany, we have this habilitation system. You want to be professor. In the industry, of course, you have to work a lot too. Maybe you have to travel a lot. So the business trips and everything. And it can happen that you lose your job from one day to the other. So I really don't know. Unfortunately, what I can see now, and really, really unfortunately, lots of my female students do not want to get children. And they even tell me.
I also hear this.
So yes.
But I don't know why, honestly.
Because they are scared. They are scared from the beginning. Okay, I get a baby now. And of course, they have to stay at home. At least in the beginning, they have to feed the baby and everything. And usually the partners are helping a lot. Nevertheless, they cannot do a lot of things. And indeed, it happened that when the students of early postdoc went back, they lost the position. It's impossible during the pregnancy or this mother leave, but after they can say that, okay, there is someone else who is better.
This is also not good.
Yes, but I have to tell you that I had plenty of students or young women with children, and they are more organized than others. So there are plenty of advantages when you are working with female researchers who have children, because they plan, they know what to do, and
maybe more responsible also.
Yes. So it's not a disadvantage, but indeed it's a very, very difficult question, and very frequently discussed issue, because, for example, my female students are coming and telling me that, okay, look at other professors, many of them, they do not have children. They do not even have husbands or a cat at home or nothing. And indeed, I should say, yes, it's true, but there are female researchers and professors who have children, family, difficult, but not impossible.
It's now people start to realize and start to create environment for these things slowly.
This is what is missing in Göttingen too.
Slowly. Hopefully, we can talk about this maybe in our next meeting. So I'm very happy that we had the opportunity to talk and to discuss things about you, your research, your opinion on some of the problems. And once again, thank you for your time and for effort. And I hope that we meet each other at some point in the future where we can talk about one of your publications more in depth. Or maybe we start an organization to, address some problems in science. Who knows? Thank you very much, Professor Antal, and hope to see you soon again.
Thank you very much. It was a very nice 1.5 hours here, and thank you for your questions. Yeah. And I hope see you soon.
Yeah. Neuroscience and beyond. Know more. Get inspired.